Okay, so now we will look at mechanics as our syllabus. As we mentioned before, we have two separations in our bodies, or the way we look at mechanics: the stationary bodies that come under statics and the moving bodies that come under dynamics. First, we look at the statics and what portion that we have. As we had a brief look about what are the forces and how we resolve it, there are two chapters associated with it. One is the coplanar forces. Now let us take a plane, a rectangular plane that we have. If we have number of forces here, as we have any system here, and there are many forces acting on one body or different body or on a system simultaneously. This is what we have to resolve in x and y component individually and find the resultant that is acting on the system. This is included in our first chapter, that is forces and coplanar forces, that is forces acting on a single plane. The next chapter that we have is under forces is equilibrium. Suppose we have, this is a Sunny Deol. Sunny Deol with his world famous hand pump tool. To remove that hand pump from which is fixed in the ground, there has to be a force applied by Sunny Deol. The force applied by the hand pump is to hold itself, hold its position. That will be acting downwards. And Sunny Deol has to apply a force upwards. When these forces are at equal instants, this force is supposed to say F, this is F dash, and when these forces are equal, they'll cancel each other and there will be no physical motion happening here. This is equilibrium. Although we know Sunny Deol's force was much greater, and hence he could easily pull out the hand pump and do the stuff that he has done. The next chapter that we have under statics is friction. We have skateboards. We all have seen skateboards, roller skates on a surface. If the surface is even, the velocity that is achieved by the person riding these boards is much higher. And if the surface is uneven, the reactional force, the force to hold back the rollers is much higher. And hence, the overall velocity act with the same force is less. This is the cause of this reduction in motion, or reduction in velocity rather, is because of the friction that is acted upon by the ground on the skates. And this is a very a physical phenomenon. Even while walking, we experience friction. If the ground is slippery, if there's water, there's oil, we tend to slip. Why? Because there's no friction. No reactional force is balancing us. So all these concepts will come under friction. We'll go through these in details. The next chapter that we have is CG and MI. CG is center of gravity. And MI stands for center of gravity is the point where the entire mass of a body is supposed to be concentrated. Suppose we have a body like this. It is an irregular body, and suppose we have a body as something like a circle or a sphere. From the structure of this sphere here, we can judge that the center of gravity would be lying somewhere in the center of the body. But when we are taking into consideration a very irregular body, it is very tough to find, something like a potato. It's very tough to find where the center actually lies. This analysis and finding that pinpoint center of gravity is done under this chapter. Next is the moment of inertia. Force which is acted upon any body the motion can be rectilinear. The force rather can cause a circular motion as well, which is very evident when we pull a door towards ourselves. It is not a straight motion, it is a curved motion. So such curved forces or actional or reactional forces the analysis of it is done under moment of inertia, and we also study what happens when a force is applied to some object. Suppose we have a football. A very common example, we have a football here and we kick it. It flies down to a point, say here. According to general study, the motion as soon as it has reached ground should stop, but that doesn't happen. It has a tendency to roll ahead as well. This is what inertia is responsible for. This is why we need to study moment of inertia to actually predict what could happen even if it has reached to a point, say from A to B, and it is going ahead. The other factor which is responsible how far the ball will go is friction. The friction. If it is a grassy surface, it will go to a lesser extent. If it is a plain surface, it will go more. If it is a frictionless surface, an ideal case, it will keep on moving till infinity. Now that is a hypothetical situation, but these are the cases which we will undergo in CG and MI, that is center of gravity and moment of inertia. The last chapter rather is trusses. Suppose we have a bridge from this point to this point. A bridge, a railway bridge or a road bridge or anything. We might have observed that these bridges are not constructed this way. The load sharing is done in this way. This is done to ensure that at these points, the force or the weight or whatever the load is not concentrated just because of a single beam, but it is divided. It is divided by various beams so that the pressure is absorbed and it does not break. This analysis of how many such beams, additional beams we need to ensure that our bridge is sustainable, we can trust upon it, and a railway or any vehicle can pass through this bridge. This study of such bridges, the number of beams that we need is done under trusses. This concludes our statics. Now we'll look at the dynamics.